No maximum time.
And we're going to talk about waves. And we're both going to talk about, or we're all going to talk about different parts of the wave. I'm going to talk about transverse waves. So that's a transverse wave. That's the Merriam-Webster dictionary, which basically says a wave that's traveling perpendicularly to the direction of energy. So it starts at this rest position, and it's caused by a disturbance. Well, transverse waves are. And so when that happens, the wave looks like this. And there are different parts to it, like the crest, which is the highest point of energy, and the trough, which is the lowest part of energy on the wave. And then there's the, that's the crest. This is the trough. And there's something called a wave period. So if the wave is traveling like this, and it starts at its crest, and it travels, and it ends at the crest again, that's the whole wave period, the amount of time it takes to make a wave cycle. And wavelength is the length from trough to trough or crest to crest. And that's wavelength. And there's something called amplitude that we talked about today, which is I don't know how about that. And so transverse wave in motion looks like this. So yeah, it looks like this because it's traveling this way, but the wave's actually moving up and down perpendicular to the way that it's traveling. Some examples are surface waves, seismographs, guitar strings, and then here's one in motion of like the wave vibrating. So this is like a transverse wave in real world. And the next one is or the last one is the heart monitor. So that's just how transverse waves are applied to everyday life.
I will be talking about longitudinal waves. And a longitudinal wave is a wave in which particles transfer back and forth, sending energy from one area to another. So I'll describe it. So in a longitudinal wave, I would use a slinky. So in a slinky, it would look like this. And basically, right here, the particles are conjoined and they're pressed together. But over here, it's out and separate, which here is called compression. And the separate parts are called rarefaction. And I will demonstrate longitudinal. So basically, when I set the slinky over there, the rarefaction and compression happened, which was when the slinky goes like this, it's compression, and it goes outward, it's rarefaction. And longitudinal waves are found in sound waves and in relays from earthquakes. Basically that. Oh.
Just open it up.
So the amplitude of any wave is from the equilibrium position, which is like this right here, this one, to the crest, which is the top, and from the equilibrium to the trough. So it's like how big and tall the wave is. That's what the amplitude is. So it's like equilibrium position is this is the equilibrium position, and this is the press, and this is the trough. And amplitude is right here. That's what the amplitude is. It's how big and tall the wave is.
So the frequency of the wave is how many waves pass through a given point in a given amount of time. For example, about 2 waves pass through this point every 2 seconds. The frequency of this rope wave will be 2 waves per 2 seconds, which would be 1 wave per second. So the unit of frequency is called hertz, which is a cycle per second. If a wave makes 8 cycles in 4 seconds, then the frequency is 2 hertz. So the frequency of the wave can change without changing its amplitude, which is the size of the wave. So this wave here has a low frequency, and this one has a medium frequency, and that one has a high frequency. They're all the same size, but they have different frequencies. So the visible spectrum, or the light that we see, is basically the colors, and these colors all have the same amplitude. Standing waves are also known as stationary waves, are a combination of 2 waves moving in opposite directions, but they have the same frequency and amplitude. This is the standing wave. If I move this way, it creates standing waves. These are standing waves. We hope you enjoyed Before they leave, any questions about waves for them? Any questions? That's good. Good job.